these four trig relationships that you've discovered and have been working with over the last month or so actually have special names. The tan being sin divided by cos and cot being cos divided by sin are also known as the quotient identities. Quotient because you're dividing the trig relationships. And cos being the reciprocal of sine and secant being the reciprocal of cos, these two are called the reciprocal identities. Not only are these relationships important in being able to figure out the exact value of an angle or to use these relationships in order to graph our trig functions, they're also helpful in simplifying trig expressions. As you look at these four identities, it's important to see that those other four trig ratios, tan, cot, cos, and sec, can all be rewritten in terms of the main two, sine and cos. And that's the idea that we're going to use to simplify trig expressions, is we are going to try to put all trig functions in terms of sin and cos. And then we'll use some of our fraction skills to simplify. So in this first example here, I want to know how much cos theta times tan theta times cos theta is. Now I certainly don't know that off the top of my head, but if I start replacing these trig ratios that I can rewrite as sin and cos, this will simplify a little bit easier. So I'm going to leave this first trig function because it's already a cos. Then I'm going to start substituting. Tan is the same thing as sin divided by cos. And cosecant, is the reciprocal of sine. So now I'm multiplying these three fractions together. I can cancel out things that are on the same things that are top and bottom. So sin and sin, boop, boop. Cos and cos, boop, boop. And when I multiply all these together, I get 1. So this is saying no matter what angle I pick for theta, when I do the cos of that angle times the tan of that angle times the cos of that angle, I will always get 1, no matter what angle I have. Next expression, how much is the cosecant divided by the secant? Well, let's see. The cosecant is the reciprocal of sine. So I'll substitute 1 over sine in for the cosecant. And secant is the reciprocal of cos. So I'll substitute 1 over cos in for secant. And now there's a couple different ways I can simplify this. I can either get a common denominator of sin times cos, or I can just use my fraction skills here. If I do 1 over sin divided by 1 over cos, that really means I'm multiplying by the reciprocal. So 1 over sin times cos over 1. And when I multiply in the numerators 1 times cos, I'll get cos. And in the denominator, sin times 1 is sin. And we should recognize that cos theta divided by sin theta is the same thing as cotangent theta. So no matter what angle I pick for theta, if I were to do cosecant of 50 degrees divided by secant of 50 degrees, it's going to be the same thing as the cotangent of 50 degrees. Here's our last expression we're going to simplify. So again, this sign right here in the middle of this expression is fine. I'm going to leave that, but I'm going to change the other two trig ratios out. So 1 over secant will really be 1 over cos. I'm going to leave my sine theta sitting there. And then cotangent theta is the same thing as cos theta divided by sin theta. So this first part of the expression, this looks a little bit nasty here with 1 divided by 1 over cos, but that's actually going to equal cos. So I can either think of it as the reciprocal of secant is cos, or if I work out 1 divided by 1 over cos, that's going to be 1 times cos, which is cos. Now the second part of my expression here, I've got some multiplication of sine times cos over sine, so I'm going to follow order of operations, do that before I do my adding. So when I multiply these two fractions together, boop, boop, the sines are going to cancel out and just leave us a cos. Plus this first cos means now I have 2 coses. Just like x plus x would be 2x, cos theta plus cos theta is 2 cos theta.